Hey guys, and welcome to the Object and Bone Constraints tutorial for Blender. This is going to go over one of the most important tools for rigging because it's one of the most advanced and versatile tools that you can use on top of the parenting and empty objects and object origin properties that we talked about before. These constraints offer you a lot more flexibility in terms of what you can do and expand the possibilities of what your rig can do. So let's talk about object versus bone constraints. So an object constraint, if you go ahead and select an object like we have this cube here, you can look at the properties tab. There is a tab next to the object properties that looks like two chain links. Now these chain links is the constraints tab. So we'll go into the constraints tab. You'll notice there's just a menu here, just a drop down menu. And when we click this menu, there's a bunch of different options. So these different options will provide a lot of utility for rigging. So one obvious one is, for example, copy location, copy rotation. These are very, very easy to understand. You basically just copy location and then you choose an object from your scene. So we can actually just do one here. Let's say let's just move that guy over there. I'm going to delete the constraint on this original one. I duplicated it. This is the object with the constraint. I'm going to go ahead and use this eyedropper tool, select the original cube, and then suddenly you'll see that I can't actually even move the cube anymore because of this constraint here. And if you see the white outline there, it actually means I'm trying to move it, but I can't. So that's one thing that you can do, and of course it exists there, but the location is going to be the same. So now I move this one, and suddenly you can see the cube is just completely constrained to the other cube. There's nothing you can do about it. Now you can also, of course, lower the influence, and you can see here it sort of follows it now. So there's a bunch of different things you can do there, and that's one of the more obvious ones. You can also do the same thing for bones. So I can actually go ahead and let's create a couple different bones. I'll create a bone here or something like that. Maybe a bone here. Let me go ahead and disconnect this bone with Alt P. It's still parented, but it's disconnected. And what I can do is I can, of course, manipulate this bone and this bone or whatever, and I can actually go to the bone constraints tab. As you can see here, there's a constraints tab for the bones, but it tells you specifically you do not want to go here for bone constraints. You want to go to the bone constraints tab, which is actually here. Of course, you can also click here, but this is where it's supposed to be. And so you click the bone constraints tab, which is right next to the bone tab, by the way. And you can see there's a very, very similar menu here, but this is for bone constraints. And you can actually use a copy rotation, for example. I'm not going to use it on the parent because that'll cause some weird problems. But I can actually, let's say, take this guy. And I talked about the rotation one also making sense. Well, it's very intuitive. I just use copy rotation. I'm going to use this eyedropper tool and select this bone. But you'll notice it doesn't select the bone itself. It actually selects the armature as an object because it's only looking for an object first. And then you select the bone. So let's go ahead and take a look at what this name is. It looks like it's bone.002. I'm just going to go ahead and hover over it and then hit Control C. It's a very easy shortcut to copy things in Blender. And I'm going to go ahead and go back to this guy. Under the bone constraints tab, we have the bone parameter, and I'm just going to go ahead and paste, and you'll notice that I can select bone.002, and now that bone will actually follow the rotation of the other bone in world space. So that's pretty cool. The location is different, but as you can see here, no matter where I put it, no matter where this where it's inheriting its location, the rotation just copies this guy. So that's basically how constraints work, and it's pretty easy to understand, pretty intuitive. We also have limit, distance, location, rotation, scale. These are also very intuitive. What we can do here is I can go ahead and limit the location. Let's go ahead and just make that as middle of the scene as possible. So this will basically, these are the different axes. Let me go ahead and drag this out here. So you can see minimum X, minimum Y, minimum Z, maximum Z. This is very intuitive to understand if you just think about it for a bit. Basically, all you got to do is set these values to a range in which this object can exist. As of right now, I went ahead and constrained every single axis to 0, and that of course makes it so that it exists only in the origin point. Again, we still have that copy rotation working. But now if we move this guy, which should be moving its children, actually no longer does, and that bone actually remains still, completely still, because it is in the world location of 0, 0, 0. Now, of course, I can up this a little bit. Let's say we make the maximum X, say, like, I don't know, 100. We'll make the maximum Y, like, I don't know, 5, some random number here. Actually, let's make that smaller. And then Z, I'm going to go ahead and do 1 as well. So as you can see here, this should give us sort of a square of sorts as the X, Y, and Z values are being constrained to finite values. So because of that, you're just limiting the location in this area. And it works great. It works exactly as intended. You can also limit the rotation of an object that's also copying a rotation. So I'm going to go ahead and remove the limit location one for now so that we can just focus on the rotation here. You can actually limit the rotation of an object that is already copying another object so that it's copying it but also applying the idea that it is limited to a certain domain. So actually let's go ahead and set the max to, I don't know, let's say 30 degrees. So it copies it up to a certain point, and at which point it just stops because it's being limited from going further than that. So as you can see here, it doesn't go any further than y of 0 and no further than 30, y of 30. So that is sorry, x of 30, my bad. But that's all world space. You can also use local space. So if you use local space here, local space is very interesting because it works a little bit differently. It requires you to think about it a little bit, and also to use the double x axis for rotation to understand it a little bit better. As you can see here, using double x actually allows you to view what that local axis looks like. You can also, of course, change this to local if you want to, and that will show you that the x-axis is now being limited. So this x-axis is limited between 0 and 30 degrees. And as you can see, if I rotate it just along this x-axis, that's the only part that's being limited. And when I move it around, it starts kind of freaking out. But that's basically what's being limited, and everything else is fine. So that's how you do it. Now let's talk about local versus global for copy rotation as well. In world space, it'll look pretty much exactly the same. As you can see here, it's exactly the same. So before we test anything else, let's go ahead and show you the importance of the constraint ordering on this stack here. So the stack of constraints, it does matter in which order it is. And you can see there's actually this arrow here that can change the order for you by moving it up or down. And this is very important because, as you can see here right now, we actually have a limited bone from the copy rotation, and the limit rotation constraint is after the copy rotation. It's below it. So it's actually applying the constraints sequentially from top down. So this is the first constraint to apply, and then the second constraint to apply is down here, etc., etc. Now the way this works is if I actually switch these two, I'm going to go ahead and move the limit rotation up with that arrow there. You'll notice that if I start rotating this, the limit rotation is no longer applied. It goes all the way around for the x-axis, the local x, which is what we limited in the options there. It should be limiting between 0 and 30, but it doesn't because it's actually limiting the rotation before it even knows what values are going to be copied. So to the bone, it's limiting the rotation of a bone that hasn't even moved yet. And therefore, afterwards, after it limits it, the copy rotation comes in. It's like, okay, let's copy it now. It forgets about this limit rotation because it already applied the limit rotation to the original local rotation, which has no copy rotation applied whatsoever. So that's very important. You want to make sure that it's the right order. Make sure that before you limit something, you have to have the constraints applied to it as well. So just to go back to the objects, it does work exactly the same way. You're going to want to use the copy rotation here, and then the limit rotation right after that if you want that to work. And then, of course, there you guys can see the x-axis is now limited entirely. But yeah, the x-axis is limited. But if you move it up, then the x-axis will no longer be limited. So it's exactly the same for objects and bones, but you just have to know that they do have different menus there. And that's it for our overview for the limit and copy constraints for Blender.